In this illustration, we intend to obtain natural frequencies of a FGM ring in the Abaqus software. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Vibration Analysis of FGM Rings Using a Newly Designed Cylindrical Super Element. In these pictures, you can observe the first, second, and third mode shapes. In these diagrams, the first, second, and third natural frequencies have been drawn for different values of n. In this diagram, the first natural frequency for different values of n has been drawn. In this table, the results obtained from the Abaqus software have been compared with those of the reference. In this question, the internal material is ceramic, and the type of that is Si3N4. And the outside material is a stainless steel, and the type of that is SUS304. The properties of which have been given in this table. In this picture, you can observe the mode shape of first natural frequency. The left picture is related to our simulation in the Abaqus software, and the right picture is related to the results mentioned in the article. In this picture, mode shape of second natural frequency can be observed. The left picture is related to our simulation in the Abaqus software, and the right picture is related to the results in the article. In this picture, you can observe the mode shape of third natural frequency. Also, in these diagrams, the results obtained from the Abaqus software have been compared with those mentioned in the article. In this diagram, the horizontal axis displays n quantities, and the vertical axis shows the first natural frequency. In this diagram, the quantities of the second natural frequency have been drawn for different values of n. As you observe, the results obtained from the Abaqus software are very close to those mentioned in the article. Here we intend to compare the results obtained from the Abaqus software with those mentioned in the article. We will consider 2 points here. 1, the quantity of natural frequencies. 2, mode shapes of the natural frequencies. Here I'll click on Allow Multiple Plot States. Plot on the formed shape option. Here you observe the first natural frequency. As it can be observed, the quantity of the first natural frequency is equal to 500 Hz. Actually, the quantity of the first natural frequency obtained from the Abaqus software is equal to 500 Hz. The quantity of the first natural frequency mentioned in the article is equal to 478 Hz. As you observe, the results obtained from the Abaqus software are very close to those mentioned in the Abaqus software. The next case we intend to survey here is mode shape of the first natural frequency. Here, the mode shape of the first natural frequency obtained from the Abaqus software can be observed. In this picture, the first mode shape can be observed. As you observe, the mode shape of Abaqus is very similar to that in the article. The second natural frequency obtained from the Abaqus software is equal to 1413 Hz, and the second natural frequency mentioned in the article is equal to 1353 Hz. In this picture, the mode shape of the second natural frequency can be observed. As you see, the mode shape obtained from the Abaqus software is similar to that in the article. The third natural frequency obtained from the Abaqus software is equal to 2705 Hz, and the third natural frequency mentioned in the article is equal to 2593 Hz. In this picture, the mode shape of the third natural frequency can be observed. As you observe, the mode shape obtained from the Abaqus software is similar to that explained in the article. Actually, here we surveyed both cases. The first case was related to the quantity of natural frequency, and the second case was related to mode shape of the natural frequency. As explained in the article, the inside material is ceramic and the outer material is steel. Here we intend to define the properties of FGM for the ring. As explained in the article, we use this formula in order to define the properties of FGM. In this formula, PR is the properties of FGM that include density, modulus of elasticity, and Poisson ratio. PM is the properties of metal. PC is the properties of ceramic. RI is the inner radius, and RO is the outer radius. As you observe, the properties of FGM are a function of the radius, and if the radius changes, the properties of the FGM will change. Here we should use this formula in order to define the properties of FGM and change the value of n each time. The quantities of n have been considered as 0, 0.25, 0.5, 1, 2, and 5, and each time we will solve the problem with a certain amount of n. Altogether, we will have to solve this problem 6 times. In the next step, we intend to draw this diagram in the Abaqus software. Here the horizontal axis is n and the vertical axis is first natural frequency. Here the diagram having been drawn with red color is the one obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are so close to those mentioned in the article. As previously told, horizontal axis of this diagram is n, and its vertical axis is the same as the quantity of the first natural frequency. Here, the diagram drawn with red color is the one obtained from the Abaqus software. As you observe, the results obtained from the Abaqus are so close to those mentioned in the article, and here the horizontal axis displays the quantity of n and the vertical axis shows the second natural frequency. Here, we intend to draw the diagram that is related to the third natural frequency,